Good morning, everyone, and welcome. I'm Carrie Burke, your moderator for today's webinar, Understanding IoT Security, How to Quantify Security Risk of IoT Technologies. You may send in questions at any time during the presentation via the Q&A chat feature. We will collect these and address them at the end of today's presentation. I would now like to introduce John Dixon, an internationally recognized security leader, entrepreneur, and principal at Denim Group. He has nearly 20 years hands-on experience in intrusion detection, network security, and application security in the commercial, public, and military sectors. As a Denim Group principal, he helps executives and chief security officers of Fortune 500 companies and government organizations launch and expand their critical application security initiatives.
Thanks, Carrie. Welcome, everybody. We've got a slew of folks on. We've got a bunch more folks joining us. We're going to jump right into this, and given how busy everybody is. But this is a presentation we put together that really highlights the difference between the world of IoT and security and testing and kind of the more traditional application security world, which is still dominated by web application security testing and maybe to a lesser degree mobile testing. But there's some attributes of the IoT world that are radically different, and they're worth repeating, they're worth emphasizing. What I hope to do is to give you enough of a sense today that is in fact the case, and that you have a roadmap for, number one, learning more, but also a roadmap for understanding how to test and quantify the risk and the questions to ask. If you are either a product manager or a consumer of or a developer of IoT technology. So we're just going to jump right into it. If you do have questions, I'll do my best to multitask and answer them. The chat function is on, and I'll do my best to answer those. So I'm going to give you a quick overview of IoT just so we have a common starting point, then dive into the security challenges that are unique. Some are unique, some are quite candidly or you'll be familiar with or relevant to the traditional AppSec world. I'll walk through briefly an IoT threat model, just so you have a sense of that difference. I'm going to solicit a little bit of input for an assessment guide we're putting together, and then, like I said, have time for questions and answers. I'm going to try to hit this right at 30 minutes, but I might go short, I might go long. So here we go. Many of y'all know me. If those that don't, I'm an ex-Air Force guy, have been in the security realm for 20 years, learned intrusion detection in the Air Force's Computer Emergency Response Team. But really what I do right now is I help chief security officers and chief information security officers push application security programs. And as part of that, I do a lot of speaking. As many of you know, I'm a frequent attendee of many of the conferences. I'm at AppSec Cali next week with Dan Cornell, my colleague here. So a lot of reading, a lot of thinking in this space. And again, I'm hopefully passing on some of that knowledge and insight that I get. The other thing is I'm a consultant. So the cool thing is we see lots and lots of client environments. So we do have a portfolio of experiences there. So the company that I run with two principals, Dan Cornell, Sheridan Chambers in the management team, is a company called Denim Group. We do a tremendous amount of application security testing and have I would say the scar tissue associated with IoT testing. We've been doing that for at least two to 3 years, if not longer, depending on how you define it. And we really work with security and dev teams to embed testing as part of a recurring program. So that's us, based in San Antonio, Texas, and Austin, but we have clients all over the planet, and certainly in the IoT realm. So our goals for today's session is to get a better understanding of IoT and the aspects of security, as I mentioned, to start to identify kind of your IQ around this realm and understand kind of where your gaps are to focus, train learning, and then ultimately, as I mentioned, is to help you ask better questions. If you are in a management role, if you're in a dev team manager role, if you're in a security role or a consultant role, is essentially to ask better questions so you can make better decisions around the risk of IoT platforms. So let's start by putting out a definition. I mean, and this is really an important part because like one of the things we do on our end is we ask the question, what do you mean by IoT? So there's some common denominators, and that is typically It's extending the connectivity out to objects and sensors and everyday items that normally are not considered computing devices, or certainly within the context of enterprise security devices. So that is all the protocols and all the connectivity associated with that, but it allows behind the scenes to exchange tremendous amounts of data without human intervention. So that's the other thing. It's really happening behind collecting data, collecting sensor data, collecting temperature data, or allowing people to interact in a seamless way. The challenge is there's no single universal definition. So as I mentioned, our first step is to say, hey, what do you mean by IoT? That's important too. So if you go, for example, to the energy sector, and operational technologies, well sensors, temperature sensors are now being defined as IoT. So that umbrella can be very broad, but it typically involves a handful of things. Think of components that have single purpose and collect data seamlessly, and I'll go into some of the specifics of that. Ultimately, it's, a layperson's devices. Computers are devices, everything with sensors running applications. So again, think versus the classic enterprise model of servers and workstations. Now you're talking lights, you're talking remote sensors, devices, cameras, everything, with streams and streams of data that are being collected and aggregated. So what is it, or how does it manifest itself in the real world? Here's all the examples I could think of in a stream of consciousness way. Smart cars, blenders, washing machines. I mean, one may argue gratuitous use of technology in certain places, medical devices, pacemakers, monitors. The point is these have been commercialized and have been included in packages in a way that it just happens and it just connects. Where you don't have to be a system engineer, you don't have to be an expert you don't have to understand how to set up a Raspberry Pi to put these things together. So that is, you get a commercial sense, a retail sense. I had to comment earlier this year for the Consumer Reports magazine about internet-connected devices and IoT during Christmas and all the different things and risk associated with that. So that definition broadens by day, but imagine everything that you could put an internet device on, or maybe you couldn't imagine, has one now. So all the risk associated with that. Again, from your perspective, from people developing product or buying product, or, what are the questions to ask? That's the perspective. And oh yeah, by the way, Crockpots. The funny story is I have a Wemo Crockpot. I pretty much use it traditionally in the form that one uses a Crockpot. So this is in my case, a gratuitous use of buying the technology just to have one. My wife just uses it regularly. And but it has a TCP/IP stack, and it can be used for a variety of things, and positively and potentially negatively. So the other thing to realize right off the bat is when you start to talk IoT is what are the connectivity models are you talking about? Is it simply a device that connects to another device? Is it a device directly to the cloud? Is it a device that has its data aggregated in a gateway that might sit in your home or might sit in an enterprise environment? If you could imagine the lighting systems that are starting to get IoT'd up, those, particularly in an enterprise environment, you would have a gateway that would aggregate all the lighting data for all the different remote lights that are throughout the enterprise. The other component is traditional back-end data sharing. You get into cloud collection model that doesn't look entirely different from many of the things we're familiar with. But the reason I state this is it isn't the IoT device. It's really the system as a whole. So in that regard, it shares a very similar parallel to the mobile application world, where it's not just the mobile code, it's the mobile code, the web services, the entry point. Think of, when you see IoT, think of it as the system as a whole. So when you're doing testing, or you're trying to sketch out the security risk, it's not just that device. It's the whole thing. Because again, attackers are going to go and find the weakest link in the system, and that might not actually be the device itself. and many times that's exactly the case. So starting point is multiple connectivity models, and then we go from there. Here's some of the challenges. Physical access. You know, the axiom of security is if you have physical access to it, you can always break it. So you start quickly getting the realm of you know, authentication and, you know, things like tamper-proof host security models and things for devices that are, you know, deployed everywhere. Many of these edge devices, particularly IoT edge devices, are single purpose. They do one thing. They collect data. They collect, you know, temperature data. They have a stream of photos. They do certain things, but single purpose. They're designed candidly for resiliency and longevity. Also, cost is a big driver, if not the biggest driver. But they're not designed to be updated. They're not designed to be scanned by Nessus or, you know, any security scanner. And so that presents some challenges, obviously, once security problems exist. The other thing is there's multiple ingress and egress methods. Think of for those that have these IoT devices at home, there's many different ways to access and to get access to them and to their core system. The last thing I would say, and this is what scares, I think, most lawmakers and public policy makers, is that, you know, many of these IoT devices are built by traditional manufacturers who are not brought up in the realm of cybersecurity like the IT manufacturers. So, you know, these are, you know, companies that build washing machines. They're not companies that build routers. So they don't have the 20-plus years of getting their teeth kicked in by attackers. They're not used to having their stuff, you know, put out on the internet and hacked. So that's another realm, is you're bringing an entire set of vendors into the marketplace that are getting to know this entire realm. And so that's a challenge. So where do we go from here, given that reality? Let's kind of dive into this stuff. So the first thing is, we would say, is that IoT threat modeling is an imperative. And for those that don't know what threat modeling is essentially taking a mindful look at the attributes of a system and trying to figure out where data ingresses and egresses, where trust boundaries exist, where data stores exist, and essentially trying to identify in a almost high level and whiteboard kind of way where the risks exist. This is an absolute imperative for threat modeling because of, number one, the dissimilar implementations of IoT. You know, again, what is an IoT? Is it an aggregation device? And secondly, you know, there's lots of moving parts, and I'll talk about that in a second. So enumerating the components of that and understanding the complexities and at least get it to a whiteboard, you know, high-level diagram is important. And sure enough, you know, where web services connect or where mobile clients are involved, that's where, you know, the threat models have problems. Or excuse me, that's where the design of these devices or sometimes implementation have problems. So that is the first starting step. We'll walk through one of those for you and give you an example and then kind of go from there. So when you talk about threat modeling, the first thing you have to do is understand, depending on the technology, that you're going to have at least 3 or 4, maybe 5 components. One is the device itself. It might be a single-purpose camera. It might be a sensor. It might be a dumb device. It might, you know, to be stuck somewhere. In many instances, there's like an IoT gateway that essentially aggregates the input from these edge devices and pushes them to a cloud. There's probably a lot of third-party web services or web services in general floating around. And then you're going to have a mobile client and a web client, typically, where that data ends up or can access data on the web client. So that's where you're going to see the traditional security flaws around application security. Is typically in those realms. And the testing coverage will be much more, you know, like familiar to those people on the call. Okay, so let's go to the next one. So let's look at this. This is a little bit of a reading test for those as I look at it. But let's talk about an IoT threat model and the components. So, again, for those that are familiar, you see where the devices are, kind of the systems that are part of the system. You have where the IoT vendor exists, the IoT user site, third-party services. Where the red lines exist is where trust boundaries exist and where data is flowing. There's a mobile client in there. So this at least allows you to know where data starts to flow and where potential weaknesses exist in your security architecture and where you probably want to do testing. And I'll walk you through an example of where the testing would apply to these different things and some of the shortcomings of this. But right off the bat, this is not your normal single database, single web server environment. And it does look very similar to mobile from a threat model standpoint because you've got, you've got a remote device, you've got web services. The big difference here being that the model can be altered massively by the difference of having an aggregation device or multiple types of aggregation devices, or in the case of aggregators, an SDK that allows people to connect to these things. So we'll talk about that in a second. But let me go a little bit further down before we go back into that. There are examples, and I would say these are very promising, and they're examples and takeaways and things that you can use to do assessments. And we are big fans of the Open Web Application Security Project IoT Assessment Framework. It at least provides a taxonomy to start to understand and start to apply certain types of security testing or controls, or at least security activities around IoT. And again, Blake breaks it down into edge, gateway, cloud, and mobile. So I'll walk through all those. So first of all, from an edge device standpoint, again, think the single-purpose device that's out there. It might be built for resiliency. It might be built for cost. What are the types of things that the types of weaknesses? And again, it has to communicate either directly to the internet via some type of service, web service, or it has to connect to an aggregation device. So the way that it communicates, is it over the air? Is it via 802.11 Wi-Fi? Is it, what are the means and how is that done and how is that secured? The classic case of default passwords that is, right off the bat comes out. And then how do you, what do you do to log activity that comes in? Where does that login exist? And is it done also in an encrypted fashion? So edge devices, again, think of single-purpose devices that are out there. There are certain activities that you need to check for to make sure there's not, certain capabilities that exceed what you designed. Again, the second area is that gateway, that aggregated device. And where we see a lot of people going right now is, at least on the home front, is building these capabilities to aggregate Nest and Ring and Hue and try to become the single-purpose aggregation device. So if you end up having one of those, or if you, in an enterprise environment, have a gateway device that aggregates, all the different outputs from a certain sensor, you have a different set of problems. So what you're going to look at is encryption upstream and downstream. Make sure that the physical access is has a way to prevent physical access and resetting the device or breaking in. Secure storage, be it local or remote. And now you get in the realm of DOSing. Is it susceptible to DOS? Can you update it? How do you update it? What's the controls associated with it? So again, this is less a device than more of a very powerful computing platform, to be quite candid, with multiple communications protocols and and probably a slimmed down server running some type of variant of OS. But the point is that it performs functions, and those functions may be unique to the actual device, and understand what it does, understanding the considerations. That OAuth gives you at least a good laundry list to start from. And then let's go on to the cloud. This is where the standard web application and cloud testing approaches and risk exist. So encrypted storage, using a secure web interface, the ability to do secure password resets, all the stuff that applies to cloud and web applications is relevant here, and traditional testing platforms that we know of and use in the dynamic and static realm fit into here. The one thing that is I would emphasize here is also is to look at third-party components. You can do that with a variety of tools, but this is where third-party components may be an important part of your testing approach. And then finally, mobile. Again, for those who have done mobile application testing, this is exactly relevant. Understanding what flows over the web application, the web services, what's stored locally, how is it stored, all those specifics of mobile testing apply here. But again, if you're looking at system as a whole, and you break down these, the mobile testing is really probably the most analogous to typical mobile testing. So let's press ahead in the interest of time. So let's talk about IoT threat modeling and security testing around that. One of the challenges with IoT testing is that your traditional automated testing tools may or may not be as effective as they are against a web application. So the type of thing you're looking at is, number one, where does the code exist? Where does the custom code exist? That lends itself to static analysis, and you are trying to find, the good news is particularly with some of these, the footprint might be small. You're also looking at web services. You can look at those via static analysis methods. If there's an SDK involved, you can look at that to figure out, how a third party might manipulate that and get some insight into that. The dynamic testing tools may or may not be relevant. Again, this is not a web or a mobile environment per se. So crafting the way you do the test and the test plan and the test coverage is particularly important. Understanding and getting some level of confidence in the third-party mobile services. You might be able to rely on the testing that others have done. You might be able to go to the vendor of components that have been supplied to you and get them to provide the results of testing. So at least, essentially cobble together a test and figure out via threat modeling where the weak links are, and that's where you focus your limited resources. So I'll go from there. And again, if you have any questions, feel free to jump in. So the other thing we're doing right now is I'm putting out, Denham Group's putting out a IoT assessment guide that really dives way further into this business problem and provides people that are buying, that are assessing, or maybe acquiring IoT solutions, allows them to ask better questions, allows them to ask vendors questions if they have vendors doing testing, to craft a statement of work a lot better. And one of the things we find as a vendor is that when we engage with clients, the acquisition process for doing IoT testing right now is very immature, and there's a lot of overhead to define what it is that we do. So really the IoT assessment guide is to provide a little bit more clarity of what we see as the common denominator. So if you're interested in that, you can DM me. That's my Twitter address, John B. Dixon, @JohnB. I love your input, and feel free to reach out. So that's in progress with a Q1 release date. There I said it. So, reach out. The other thing I want to emphasize, a couple other things here real quickly, are because of the consumer nature of IoT, there is a lot of attention right now by public policymakers. And although all the guides up to this point, particularly from the Federal Trade Commission and others, have been voluntary in nature, there is, I think, lawmakers in D.C. and other places are casting a wary eye on IoT development just because of the war stories and some of the horror stories about, internet-connected devices, IoT-connected devices, creating risk for children, for example, and others. So I think if you are a security person responsible for assessing, building, reviewing IoT technologies, a strong recommendation is to keep one eye on the policy side of the house, because as more public breaches happen, I see far more scrutiny from elected officials and from policymakers and regulatory agencies on this area, far more than traditional stuff. So stay tuned on that realm. A few references that I pulled for this presentation: the OAS IoT framework I mentioned, IoT from the Internet Society, the IoT overview. There's no shortage of information out there, but I would say this is a fast-growing and relatively immature space. So, you know, we're kind of on the bleeding edge of this, as of many of you on the call. So if you do have interesting and other resources, feel free to share with others, and you know, always growing the body of knowledge here. So with that, I'll wrap up, and I appreciate your time during a very busy January. For those that gave up their lunch for today or eating their lunch while they're watching this, thank you for joining me. That's my Twitter address below. There's my email address as well. I have time for some questions and answers, and feel free to use the chat function to send those to me. So, here's the first one that came in, and what's the most important thing about IoT testing? That was okay. That was a good one. I would say it's the number one, threat modeling, and then number two, taking the threat model to craft a custom test plan given the wide range of IoT technology implementations. Like, there's not a standard template at this point, and then understanding. You know, again, you asked me to look at a device, a gateway, or the cloud component, or the system as a whole, and that will allow both the buyer and the seller, be it consultants or even internal testers, to know what the scope is and understanding that. So that's a great one. The second question is about testing tools. What testing tools do you recommend for IoT testing? Okay, that's a pretty specific question that we've got. As I mentioned, the static analysis tools that are out there do very well for the source code, and you know, the market-leading ones are IBM AppScan Source that are out there. The Micro Focus, Fortify, and Checkmarks are the ones that probably come up most in conversation. Those lend themselves to the source code analysis. We obviously use Burp, and others use some type of proxy to intercept traffic between the devices, although those are optimized for web many times. And then just looking at traffic between the traffic analyzers in certain instances to see what headers and footers are going. Those are good. So your Wiresharks and others are good for looking at the ground truth of what's going out. Okay, I think those are the only two questions I have from the audience. But I really appreciate you attending. I was going to also let you know one last thing. We're recording this, so this will be out there for perpetuity. You'll also get to hear my somewhat shaky voice. I'm just bouncing back from laryngitis. So this will be out there. If you have any other friends or colleagues or bosses that you think would benefit from this, and you think this information is valuable, once that's up, we'll send this out to everybody. Feel free to forward it, and again, you know, borrow what you can, send me any questions that you've got, but appreciate taking time out of your busy schedules to attend. And with that, I'll wrap up.